Sociology is the scientific study of human social behavior, and this definition presents a couple of questions that we should resolve before we get started. Number one is, what is a scientific study, and what is a social behavior? Let's take these in order. The definition of science is the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural universe through observation and experiment. Science is what we call an epistemology. And in philosophy, epistemology is the study of ways of knowing. Science is a particular way of knowing, and it's a way of knowing that's concerned with empirical reality. And scientific claims are established on the basis of empirical evidence. Scientific claims must be independently testable and falsifiable. You have to ask questions that have answers that can be provided through empirical evidence. You have to be able to test your claims against evidence, and you have to be able to know when you're wrong. Keep this idea of testable and falsifiable in your mind while we talk here. Science is also amoral. And amoral means without morality. The prefix a means without. An atheist is someone without belief in God. Amoral is without morality. Now, in colloquial speech, we talk about someone that doesn't have any morals as being a bad person, but what we really mean is a person has bad morality, is immoral. Amoral is not the same as immoral. So let's go through these. Testable claims, falsifiable research. These things are important. Right? So think of the kinds of things that we know that science has learned over the past few decades. So for instance, these days we know that cigarettes cause cancer. Cigarettes cause lung pathologies. And you take for granted that we know this, but it's not something that we've always known. In the 1950s, there was no clear idea that cigarettes led to any kind of lung pathology or lung cancer. It's only when pulmonologists and other physicians started talking at their conventions or communicating with one another and saying, I notice a lot of my patients that smoke have lung pathology. And it was at that point that epidemiological studies began to find the link between cigarette smoking and lung pathology. And it really wasn't until the 80s and 90s that this became widely, generally known and accepted. It wasn't until the 80s and the 90s that the body of evidence confirming the link between cigarettes and lung cancer became incontrovertible. And that was done through a scientific practice that we call replication. No one scientific study is definitive. And what happens is scientific studies begin to show the same things over and over and over again. And when you have a preponderance of studies that show the same thing over and over and over again, then these claims rise to the level of scientific truth. So a true scientific claim is one that cannot be falsified. A true scientific claim is one that has not been able to be disproved. Now, we never say that scientific claims are absolutely true, capital T true, because, as the last sentence in this slide demonstrates, scientific knowledge is tentative. Okay? Now, think about things that are not testable or not falsifiable. So I have an aunt who believes that Hurricane Katrina is God's punishment because the city of New Orleans is accepting to gay people. She brings this up all the time. She looks at natural disasters and see where they hit and, tries to determine what the sins were of the people that were wiped out by these natural disasters. Now think about the claim that God sometimes uses natural disasters to punish people. There's ample biblical precedent for this. There was a flood that wiped out the whole world because of sin. The city of Sodom and Gomorrah was wiped out with flame and fire because of sin. So there's ample precedent for this in our theology. But the claim that God sometimes uses natural disasters to punish people is not a scientific claim. How would you go about testing that? How would you go about proving it false? Right? That's just not a question that's fit for science. Or even more fundamentally, the idea that human consciousness survives the death of the body. Is there an afterlife? Well, we don't know. Uh, there have been all kinds of claims of people that have come back to the dead, but none of these things are definitive. There have been reports of near-death experiences, but these haven't really conformed to laboratory conditions such that they convince most scientists. Okay? There are some things that are not presently observable and amenable to experimentation that could become fit subjects for science if we discover them. Right now, the notion of life on other planets is pure conjecture. Is there life on other planets? The only answer to that question is we don't know. Lots of scientists will say that it's plausible, but the answer to the question, is there life on other planets, is at this time unknown. Now, if we find bacteria on Mars, or if we find life on other planets, then the scientific questions will shift. And you say, oh, well, a lot of people have seen UFOs. Have you ever seen a UFO? The interesting thing about UFOs is that they hardly ever land at the Princeton Observatory. How come it's always, on some dark night out in the wilderness that people see a UFO? How come one has never landed on the Mall in Washington, D.C.? There may very well be UFOs, but so far there haven't been any sightings that rise to the level of a independent, testable, falsifiable observation. Okay? So let's talk now about this idea of amoral science. Science is not in the business of determining what's right or what's wrong. Science is engaged in the business of determining what is or what isn't. So science can't comment on whether or not something is morally correct or not. So my field is the sociology of religion, and people often ask me, which religion is true? And my answer to that question is, yours, or all of them, or none of them, or whatever. There is no scientific answer to that question. How would I test to see which religion is true? It's not a scientific question. A lot of the questions that we have in our political debate now and in the past are not scientific questions. Should gay people be allowed to marry? That's an ethical question. That's a philosophical question. That's a legal question. That's a theological question. It is not a scientific question. Does life begin at conception? Is destroying a blastocyst the moral equivalent of killing an 18-year-old child? Here's a picture of a zygote on the end of a hypodermic needle, little tiny cells dividing. Is that, if I destroy that, is that the functional equivalent of killing an adult human being? Well, that's not a scientific question. Now, science has some things to say about this. For instance, science can tell you that there's no central nervous system in that zygote. It does not have consciousness in terms of its complexity. That particular blob of cells dividing is less morphologically complex than the eye of a housefly. But that doesn't settle the debate. Its complexity, its morphology, that is not what determines whether or not someone is or isn't the moral equivalent of an adult human being, because that's not a scientific question. That is a religious question. So in many respects, science and religion operate in separate spheres. Science really can't impinge on the religious realm, and this is why we'll always need religion. Now, a lot of people are very afraid of death, and when it comes to your fear of death, there's nothing science can do for you. You're not going to go to your psychiatrist and say, oh, doctor, I'm terrified of death. What can you do for me? Whatever your psychiatrist says, she's not going to say, oh, don't worry about it. You're not going to die. You are going to die. And science has nothing to say about what's going to happen to you after you die. But religion does. Religion has a lot to say about what happens to you after you die. And so if people are concerned about death and they have a desire to believe in the hereafter, religion has a monopoly on that. Science will never get into the religion business. And as you can see, there are lots of things about science and religion that don't overlap. But sometimes religion can make empirical testable claims that are subject to scientific scrutiny, and this is where the conflict arises between science and religion. When religion makes claims that are testable, falsifiable, based on the observable empirical world. Now, regarding the claim of which religion is true, this is a DC-8. And in the religion of Scientology, there is a doctrine that states that the ancient alien Lord Xenu came to this planet 75 million years ago in a spacecraft that looked like a DC-8 but was capable of intergalactic travel. And aliens were brought in this DC-8 and they were stacked up into volcanoes, and then those volcanoes were blown up with hydrogen bombs. And the sort of remnants of these aliens exist today, and they infect our bodies and they graft onto us, and that's how we end up being sick or unhappy or fearful. I hope I haven't completely misrepresented the beliefs of Scientology, but even if I stated them 100% correctly, most of the people listening to this would say, yeah, that's incredibly implausible. That is, I don't know what a craft capable of intergalactic travel would look like, but I know that it would not. I think it would not look like a DC-8. There isn't any aerospace engineer that would say, yeah, there's a machine that's fit for intergalactic travel. Now, who could believe something so scientifically implausible, right? Well, many of you or many of your friends or many of your neighbors believe in things that are just as scientifically implausible. If you want to believe literally in the text of the Bible, for instance, then you believe that every animal on earth traces its provenance to a single pair that was put on a boat by a 500-year-old man named Noah 4,500 years ago. Now, I'm not saying that is or isn't true, but there aren't any scientists that are going to endorse that claim in peer-reviewed scientific journals. There are no, in other cultures, there are no Chinese zoologists or Korean zoologists or Japanese zoologists who are doing research on speciation that are on the trail of this 4,500-year-old boat theory. No one lacking a theological stake in this claim believes it. So this is an example of the kinds of things that we see where there's a conflict between science and religion. People don't generally use scientific reasoning in their everyday life. The chapter that you read talks about the difference between science and everyday reasoning and points out some of the errors that people make in their use of common sense or everyday reasoning. Let's define common sense as a basic ability to perceive, understand, and judge things, which is shared by nearly all people and can be reasonably expected of nearly all people without any need for debate. Now, the fact that it's not up for debate doesn't mean that it's necessarily true. Now, common sense works in a lot of instances, but the chapter points out problems with common sense thinking, and let me give you a couple examples. First things first. Here are a list of some of these kinds of errors in reasoning that the chapter points out. And we're going to go through each of these in turn. Part of the reason why people make errors in reasoning is because psychologists will tell you that the human brain is not necessarily engineered to provide correct answers. The brain does not give equal weight to every observation. We give more weight to observations that command our attention. We give more weight to observations that confirm our existing beliefs. Instead, your brain is engineered to provide satisfying answers. And for most people, a satisfying answer is one that is plausible enough and that confirms what you already think. So for instance, let's take these in turn. The idea of selective observation. If you've ever bought a new car, one of the things that happens when you buy a new car is you start seeing cars just like your car all over the road. This might lead you to believe that lots of other people have just bought a car like yours. No, now that you have such and such a car, you just start noticing all those cars that were already on the road that were like your car. Some people will say something like, oh, God, my phone always rings whenever I get in the shower. Well, you happen to notice and remember when your phone rings when you're in the shower because it's inconvenient. But there are lots of times when the phone rings that you just answer it in a perfunctory way or ignore it in a perfunctory way without thinking about it. So it only seems like getting in the shower makes the phone ring. This is an example of 1A, selective observation. Only noticing certain observations that command our attention or that confirm our existing beliefs. This is where many stereotypes come from. I went to graduate school in the New York City area. I moved there from a small town in Utah. And a lot of people told me, oh, be careful because New Yorkers are rude. Now, imagine how easy it would have been for me to simply take that advice to heart and tabulate every time someone was rude to me and really not sort of pay attention to the times when people were nice to me. You can see how it would be easy to construct that kind of a stereotype. And that is exactly where stereotypes come from. I might notice instances when New Yorkers are rude because I have a preconceived idea about that, but overlook instances when they're not. Now, sometimes our observations are just plain inaccurate. And let's look at 1B, inaccurate observation. One of the things that we know from social science research is that if you ask people about their perceptions of crime in America, most people will tell you that there was more crime this year than there was last year. And here's some data over time, and you can see that people believe that there's more and more and more crime in the United States. And we ask people various questions. You can say, just ask them straight up, is there more crime in the US than there was the year before? You can ask people questions like, is there any place within a few miles of your home where you would be afraid to walk alone at night? Or you could ask, how worried are you that you or a loved one might be burglarized or harmed by crime? However you measure it, fear of crime is up in the United States. And why is this paradoxical? Because, in point of fact, the actual crime rate in the United States has fallen. And it has fallen dramatically. We'll learn this when we get to the sociology of deviance in a few weeks. The crime rate, as measured by the FBI, seems to have peaked in the early 90s. And commencing in the early 90s, it began to fall, and it fell precipitously and continued to fall until about 2009, 2010. And ever since then, it's been sort of scraping along the bottom. Imagine like a bumpy trough at the bottom where crime can't seem to go any lower than it's already going, but it's just, moving along. Most people think that the crime rate has gotten as low as it can possibly get. In some cities like Boston and New York, the crime rate is generally as low as it has been since we started measuring crime statistics. And this is true nationally. Here are some national figures. And this is true in municipalities. Here are news reports that I've gathered from all around the nation, in large cities, in this or that county, in Florida, all over. And it is true with respect to all categories of crime. Here is a chart showing violent crime. And you can see the peak year was in 1994, and then the drop began. And this is really weird because we have a general paradox here where the number of people this is a poll from the Gallup organization, the number of people saying that there's more crime in the US simply doesn't track with the violent victimization rate. Now, what is going on here? Why are more and more people afraid when the volume of crime has dropped? Why are more and more people afraid year on year when, since, say, 2009, 2010, the crime rate has been pretty much stable? Well, think about where most people get their information about crime. Where do they get it from? Well, they get it from the media. And in journalism, There is a famous saying, maybe you've heard it before. The saying is, if it leads, if it bleeds, it leads. Now, what does that mean? If it bleeds, it leads. What it means is that carnage sells. I always ask my students in the sociology of deviance to ask themselves, what is the 11 o'clock news for? What is the newscast for? And the answer to that question, I think, is to make money for the station. I mean, the purpose of the 11 o'clock news may be ostensibly to inform you or to let you know what's been going on in your town that day. But really, the station is attempting to sell advertising and make money with that newscast. And they make money by getting people to watch their station. It's a matter of ratings. And so how do you get ratings to go up? Well, there's a lot of competition for your eyes. Cable packages have hundreds of stations. And so increasingly, the news has turned to stories about crime and, stories about the danger that people are in, when objectively they're not in more danger. But these perceptions, people's observations of the news, lead to inaccurate conclusions about the safety of their society. The way I like to explain it is this. Have you ever watched a football game? The nice thing about school starting again is that football's back. Have you ever watched a football game and then after the football game you watch the highlight reel of that game on the newscast? Well, what kinds of plays make the highlight reel? Plays that score. Plays that are highly unusual. Plays that change the tenor or the outcome of the game. That's what makes the highlight reel. You never see, a play that's blown dead for a false start or something like, something banal like a fullback dive up the middle. Well, what I want to tell you is that the entire newscast is a highlight reel. That what you see on the news is as representative of what happened in your town that day as the highlight reel is of the game. And that is the reason why people are substantially more afraid than they really need to be about crime in our society. And that is why people think that the United States is becoming more and more and more dangerous when that is objectively false. Crime has declined and declined rapidly. One other thing that I want to do with crime statistics is to make a more general point about how statistical data should be used in the social sciences. What we'll see is that sociologists tend to make claims that they support with statistical data. We use statistics as evidence, and you'll see a dazzling array of statistics in this class. And almost everybody uses statistics these days. In election years, you will be inundated with polling data that you will be expected to make sense of, and other claims about what people think that you will be expected to make sense of. I've included some reading in a little book called How to Lie with Statistics that will show you how people can manipulate statistics to serve their ends. And that reading is there to help you make good decisions about statistical claims that you see in the media, because lying with statistics is a cottage industry. Also, there are lots of ways that statistical claims or numerical claims can be misleading. In the top half of this chart, you see the number of homicides in 2012, New York City versus Jacksonville. And you can see that New York City had 419 murders in 2012. Now, that's a lot of murders. I lived in New York City, and one of the things that I noticed was the frequency of horrible things, murders and just awful things that you would see on the nightly news. one of the interesting legacies of a bygone era is the fact that no matter how large a city is, it tends to have only one CBS affiliate, one ABC affiliate, one NBC affiliate. And so what ends up happening is the local news for New York City covers the entire region, and almost every night, horrible things happen. And so if you used the nightly news as a gauge, you would think that New York City was an incredibly dangerous place because there is, on average, more than one murder per day. In Jacksonville, by contrast, there in 2012 were fewer than one murder every 3 days. So I've never lived in a place where the weather is so often the top story like it is in Jacksonville. There's just not enough carnage to fill a newscast every single night. And so I think the casual observer might conclude, based on the raw numbers, that Jacksonville is a safer city than New York City. But the bottom half of the slide shows what happens when you adjust this for population. And as we'll learn later, murder rates, crime rates are standardized per 100,000 people. And so what you see is that in actuality, Jacksonville's murder rate, 11.1, is more than twice as high as New York City's murder rate. So all things being equal, in 2012, you were more than twice as likely to be murdered in New York City as you were, or excuse me, in Jacksonville as you were in New York City. And so the lesson to learn from this is that raw numbers without percentages are bogus. Right? Now, let's look here at Jacksonville's murder rate. And here is the rates by year. And you can see it goes up, it goes down, but there really isn't anything that you can see as a trend here. It seems to be, you know, if you were to draw a straight line through it that constitutes a trend, it would be fairly flat. But one of the things that I want to teach you is that in addition to raw numbers without percentages being bogus, percentages without raw numbers are also bogus. And I'll show you how charts can be made to be misleading. First, I want to share with you something that I heard on the radio a few weeks ago. And it was a report about a survey called the National Longitudinal Survey of Youth that is given to high school seniors every year. And the news report said that heroin use had doubled among high school seniors, a 100% increase in the number of high school seniors who said they'd used heroin the past 30 days from 2014 to 2015. And I was like, my God, that's awful. And so being the sociologist that I am, I went home to look it up. I can't imagine any high school seniors using heroin, and I can't imagine heroin use doubling from 2014 to 2015. And what I discovered was that yes, heroin use actually had doubled from 0.2% to 0.4%. Now, is that really noteworthy? No, I don't think it is. But why does that make a headline? Because the percentage without the number is as bogus as the number without the percentage. Look at this chart here, and let me show you how this can easily be done when you exaggerate these kinds of things. On the top, I have a sample headline that you might see from the chart on the previous slide. Headline, Jacksonville murder rate relatively stable in the 21st century. But if you just look at the change from 2011 to 2012, you can see that it went up. And now look at the chart that I've made down below, just showing the difference between 2011 and 2012. And imagine headline number 2, murders in Jacksonville up dramatically from last year. You see how that kind of lies with statistics? Now look at those two headlines and tell me which one you're most likely to see in the newspaper. So what I want you to do is to think about the difference between scientific reasoning and common sense or ordinary logic, and think about the ways that science can help us have reach better conclusions about the nature of social life. And then I want you to think about all of the pitfalls and hazards that are involved in statistical reasoning and how you can avoid those subsequently in your life, and how you can apply those skills to the kinds of statistical reasoning that we're going to use in this class.